CuriosityStream is the streaming service for people who want to know more. And now check out Curiosity's new series, Queens of Ancient Egypt. When pharaohs held the throne, their wives held the power.
We see her taking precedence over the pharaoh, an absolute mastermind.
All hail the queens.
This is unprecedented.
Watch Queens of Ancient Egypt now on CuriosityStream. With monthly, annual, and bundled plans. Find the one that works for you at curiositystream.com.
Well, shopping for a car?
Yep, Carvana made financing a car as smooth as can be.
Oh, yeah?
I got pre-qualified instantly and had real terms personalized just for me.
Doesn't get much smoother than that.
Well, I got to browse thousands of car options on Carvana, all within my budget.
Doesn't get much smoother than that.
It does. I actually wanted a car that seemed out of my range, but I was able to add a cosigner and found my dream car.
It doesn't get much...
Oh, it gets smoother. It's getting delivered tomorrow.
Visit Carvana.com or download the app to get pre-qualified today.
Good day, everybody, and welcome to the Astronomy Daily podcast. My name is Tim Gibbs, and I will be your host for today's episode.
Astronomy Daily, the podcast, with your host, Tim Gibbs.
First of all, I would like to thank all of our listeners for getting us into the top 5 of the astronomy podcast charts and in the top 100 of the science podcast charts. Thank you very much to everybody. We are truly humbled, both Steve and I are. Now, as usual, I have my digital AI reporter, Hallie, in the studio with me. Now, Hallie, I understand you did an extra show with Steve.
Hi, Tim. Yes, it was great to do an extra episode and unexpected as well, but always fun to do episodes with Steve.
Great, well done, Hallie. Now, do you have some news headlines for us this week?
I do indeed. Here are my top stories. NASA's Lunar Trailblazer satellite is ready to hunt for water on the moon. Lunar Trailblazer joins a growing list of probes and landers heading toward the moon to search for water ice. NASA's Lunar Trailblazer mission is almost ready for liftoff. The Lockheed Martin-built Lunar Trailblazer satellite is fairly small as satellites go, measuring just 11.5 feet, 3.5 meters, wide and weighing around 440 pounds, 220 kilograms. When it launches no earlier than 2024 on a yet-to-be-determined rideshare mission along with the Intuitive Machines IM-2 mission, it will hunt for water on the moon's surface and attempt to map its abundance and distribution. The satellite recently received the second of its 2 instruments, the Lunar Thermal Mapper, LTM, sensor built by the University of Oxford in England. LTM is designed to use infrared light to map the surface temperature of the moon as well as mapping variations in the minerals that make up the lunar surface, according to a Jet Propulsion Laboratory, JPL, statement. Doing so will enable the satellite to identify lunar locations where water might be found. Designing, building, testing and now delivering LTM for its trip to the moon is a fantastic example of the innovative and dedicated teams at Oxford and across the UK, especially given the challenges of the recent pandemic. University of Oxford physicist Neil Bowles said in the statement. The data from the mission will help us to understand how water is transported across the surface and potentially captured in cold traps near the lunar poles, allowing follow-up from future human robotic exploration. Human missions to Mars necessitate an efficient launch system to ascend from the planet and rendezvous with Earthbound return vehicles. The critical component for this ambitious task? Oxygen. Not only for ascent propellants, but possibly also for life support. To facilitate a crew of 6 astronauts, approximately 30 metric tons of oxygen propellants would be required for ascent. This significant amount would be cumbersome and costly to transport from Earth. The solution? Produce it right on Mars. Drawing oxygen from Mars' abundant carbon dioxide, CO2, presents a significant advantage. This innovative technique is part of an approach termed In Situ Resource Utilization, ISRU. Recent accomplishments, such as the Mars Oxygen ISRU Experiment, MOXIE, project, have demonstrated the viability of a prototype system that can successfully convert Martian CO2 into oxygen, O2. Now, the focus shifts towards elevating this prototype into a fully operational system. In their latest research, published in Space, Science and Technology, researchers Donald Rapp and Eric Hinderman lay the groundwork for a full-scale Mars ISRU system. Their model proposes producing 30 metric tons of liquid oxygen over 14 months, accounting for the diurnal and seasonal shifts in the Mars environment. Using the 500-meter aperture spherical radio telescope, FAST, a research team led by Professor Han Jinlin from the National Astronomical Observatories of the Chinese Academy of Sciences, NAOC, has detected distinct dwarf pulses from a bright pulsar PSR B2111+46, and studied the radio emission in unprecedented details and probed the unknown physics in the magnetosphere. Pulsars generally emit periodic radio signals. However, some old pulsars occasionally quench for some periods, a phenomenon known as a pulse nulling. Perhaps the particles cannot be produced in the magnetosphere due to improper conditions or changes in the magnetic field structure and radiation region, or the area for particle creation is then flooded by plasma produced in other areas. The exact reason for the absence of pulsar radiation is a mystery because it is impossible to probe the physical state of the pulsar's magnetosphere when radiation is quenched. PSR B2111+46 is a relatively old pulsar, and scientists have long known that emission from this pulsar often nulls for periods of time. However, dozens of unusually weak, very narrow pulses, previously unobserved, were detected during ordinary nulling periods when it was serendipitously observed on August 24, August 26, and September 17, 2020, as part of the Galactic Plane Pulsar Snapshot Survey, a key project of the FAST to hunt pulsars. To verify this new kind of emission state, the researchers observed this pulsar for 2 hours again on March 8, 2022. Finally, we picked out 175 such narrow, weak pulses, said Dr. Chen Shui, the first author of the study. According to Dr. Chen, such pulses stand out from normal pulses in terms of pulse width and energy, and thus have been named dwarf pulses.
The Astronomy Daily Podcast.
Thanks for that, Hallie. Now, I want to talk about one story today, and this Russia's Luna 25 probe crashing on the moon. The Luna 25 probe, Russia's first moon mission in almost 50 years, has crashed on the moon after an incident during pre-landing maneuvers, the Russian space agency Roscosmos has said. Communications with Luna 25 was lost at 2:57 p.m. on Saturday. According to preliminary findings, the lander has ceased to exist following a collision with the moon's surface. Yes, I'm sure Russia has been spending too much money on a war somewhere rather than spending a decent amount of money on research. My personal view, but moving on. Measures taken on August the 19th and 20 to locate the craft to make contact with it were unsuccessful. The space agency said an investigation would be launched into the causes of the crash, without giving any indication of what the technical problem might have occurred. With Luna 25, Moscow had hoped to build on the legacy of its Soviet-era lunar programming, making a return to independent lunar exploration in the face of growing isolation from the West. The 800-kilogram Luna 25 probe was to have made a soft landing on the lunar South Pole, the first in history. Russia has not attempted to land on a celestial body since 1989, when the Soviet Union's ill-fated Phobos 2 probe to explore the moons of Mars failed due to an onboard computer malfunction. Roscosmos boss Yuri Borisov has said that the venture would be risky, telling President Vladimir Putin face-to-face in June that the probability of it succeeding was around about 70%. Now, Hallie, do you have a terrible joke for us this week?
Why did the Scarecrow win an award? Because he was outstanding in his field of conceptual physics.
The Astronomy Daily Podcast.
Thanks, everybody, for listening to Astronomy Daily. You can find all of our episodes, plus our parent podcast, Space Nuts, at spacenuts.io or at bytes.com. And don't forget you can join in the conversation yourself by going to our Facebook page, Space Nuts Podcast Group. You can hear Steve Dunkley on Mondays and myself, Tim Gibbs, on Fridays for a full show. Thanks for listening. See you next week. Bye for now.